So what you see in the dashboards now is the understanding of each data that's coming now is being transferred to the cloud, and you can monitor this from anywhere. Either if you have multiple plants and you're monitoring multiple operations, this allows you to have a pulse check on what happened, today. What's my shift data? Or how many loads that came in, and what was the agreed size distribution for each of them? How my run-of-a-mill operation fared, for today's shift. Whether we are producing what we really needed, maybe yes, from the overall tons perspective, but what's happened? Are we producing too much fines after the primary crusher? And that's where it gives a good understanding, because the fines are made, as everybody says, in the crusher. So what we can do to avoid those crusher gaps. So this information, as you have now in the dashboard, you can start to understand really and dial down on the blasting side. So passing this information to the blasting team and working in conjunction to come up with a pattern that avoids this, scenarios of not meeting the size definition that our crusher expects. But more importantly now, as you can see, now you have a good understanding of what the data is coming and what's happening in the plant. But how do we correlate back to the mine now? And that's where this mine-to-mill tracking comes, which means geospatially tracking which blast or which shot ended in the crusher. So you have a blast pattern and the muck pile data from your mine, which means you're analyzing and designing the shot. You have the XYZ position of each drill hole data. And then after the blast happens, you have the blast fragmentation data that can be correlated now to what happened for that specific load in the crusher. And how we can do that is we apply the smart GPS tagging to each truck load that is coming to the crusher. And the camera has an identifier to correlate each timestamp along with that GPS ID for that truck or loader or whoever is, whatever type of equipment is bringing the material in at the plant. And you can specify the blast zones with the blast ID and see what's the activity as well when the material was loaded and when it was brought in at what timestamp. And all those data can be correlated to that specific load blast ID with that specific throughput of the plant as well. So another powerful correlation can be drawn now to really understand what's happening from my mine to the mill now. And what it gives you a good understanding of whether the pattern that we had performed average, best, or okay. So that's something you can start drawing. Not only that, you can also start drawing very granularly by each drill hole, which you can see how each hole energy consumption got correlated to the throughput, because now we have that location ID and the hole ID to correlate to that specific load. So the relationship between the mill throughput and powder factor can be drawn, which can be used now further to understand my correlation of what's my dry fines, wet fines, particle size that came in, and really drawing this yield improvement. So the daily yield improvement can be done for each blast now, or even further, like each day. So this data now, it's in your fingertips. It can help understand really the aspect of what's going on from start to the finish. Furthermore, now we have the data to understand. You can draw scenario analysis. So now we have the data from what's happening in the mine, what we designed the pattern, how it ended up in the crusher, or even further run of a mill. Now, if we use the same data to calibrate our next blast design, what it will look like. So the scenario analysis to understand if I change my powder factor, if I change my pattern, and am I getting the same D50? Or maybe I change certain parameters now, which can result into more optimized pattern. But now I have a data to play from the myth. So having this type of analysis with the real data can really make adjustment in the pattern that you're looking for here. And predicted data, prediction that comes out is now calibrated data from the mill now. So really understanding where we want to be and how we want to go forward in the each blast by blast, or maybe if your geology is changing, in order to track that as well, those map pattern considerations, can be done now. So usage of all these tools, allows you to build an entire optimization program, from start to finish. As you can see, correlation from fragmentation with drill design and correlation of crusher throughput data or the crusher data or the run-of-the-mill data further at the belt. It is hugely useful how improvements can be made at the mine, at the bench now. What it differentiates, it's all these data sometimes is very hard to handle. So you have the differentiators in terms of the AI models now, which is automatically structuring this granular data in one single place, which doesn't require any bulky integrations or workflow. You start to see this play again and again, and you can start to do the correlation. And this data can be fed from all across the value chain. And you can see this not in a siloed way, but in one single place in the database structure here to see and monitor the different conditions in a much more visual way. And it also brings contextual information, that's why geospatial contextualization is very, very important, because if you're designing a blast in the same mine in one specific pit, but then the geology changes as you're tracking down different seam, how does that impact? So geospatial understanding and layering the data in that contextual way gives you a good understanding of how each geology are performing differently now. And then correlation with the time series as well. What happened at what time series instant.